Hi everyone, today in Integrated Math 2, we're going to go over Chapter 10, Lesson 2. Oops. Here are the objectives. Make sure you write them down in your notes. Alright, so the first thing we're going to go over today is the Pythagorean theorem. In a right triangle, this is very important, it must be a right triangle. The sum of the squares at the lengths of the legs is equal to the square of the length of the hypotenuse. So when we're talking about legs, we're talking about I'm going to show it as L. We're talking about A and B. Both of these are legs. And then C is always the hypotenuse, which is always going to be the largest side. And our formula that we're going to use, if and only if it is a right triangle, is A squared plus B squared is equal to C squared. Alright, so as you can see here, we're going to be using the Pythagorean theorem. I know we're going to be using the Pythagorean theorem because I see a 90 degree in a triangle. So remember, we have our formula, which is A squared plus B squared is equal to C squared. So that's really important. So we know A is 15. 15 times 15 is 225. B is equal to 9. So B squared is 9 times 9, which is 81. And if we were to calculate this out, let's say we did not know what C was. So once again, remember we said our formula was A squared plus B squared is equal to C squared. A squared is 225 plus our B squared, which we said was 81. And let's say we didn't know what C was. So we're going to leave it as C squared. When we add these up, 225 plus 81, we're going to get a total of 306, which is equal to C squared. And I just want to find out what C is. So I'm going to square root both sides. That's the only way this square is going to go away. So C is equal to 17.49. And there we go. So here we have something called the common Pythagorean triples. For example, if we have a triangle that's a 3, 4, 5, I know that 3, 4, 5. I know that this is going to work. It's just one of those ones that you see a lot and it's very common. If you want to prove it, we can do that real quick. So 9 plus 16 is equal to 25. 25 is equal to 25. And that's what you wanted. So here we have the common Pythagorean triples that you just see automatically and that you should become familiar with. Some are more common than others, but these are the main ones that you'll see. So 3, 4, 5, and they could be a variation of 3, 4, 5. Notice from here to here, we have 6, 8, 10. Well, what happened was they were all multiplied by 2. And the same case for 5, 12, 13, 8, 15, 17, 7, 24, 25. These are just ones to make your life a little easier when dealing with Pythagorean theorem. Next, we have converse of the Pythagorean theorem. So what this is saying is if you have A squared plus B squared is equal to C squared, we already know that's a right triangle. We're just going in the reverse of what we were saying before. Before we were saying if we knew that we have a right triangle, then and only then we can use a squared plus b squared is equal to c squared. That's what, when we're talking about the converse is always just like the flip version. Notice the if and thens, they swap when we're talking about the converse. Those if-then statements switch. Next we have Pythagorean inequality theorems. So notice it's the same idea, but we're switching it a little bit. This one is saying that if we have c squared, which is less than, makes that squished L, a squared plus b squared, then we know that triangle ABC is acute. And then we also have another theorem saying if c squared is greater than, I know it's greater than because it makes that weird G, then a squared plus b squared, then triangle ABC is obtuse.